5 2 3 6 3. Right, this is the number. One more thing is given, the number represented in the base 7 system. So this is base 7. Okay, this is not octal number, right? For this number, this 7th complement, that is r's complement, right? If it is an octal number base 8, then this will be r minus 1's complement. Okay, so now as this is the 7th complement, or we can say r's complement, the general formula for r's complement is, right, what you need to do, write that number as it is from right hand side. Start from right hand side, then this number you need to subtract from r. Is it a r's complement? So subtract from r, rest from r minus 1. So r is 7, rest is 6, right? So 6, 6, 6, 6 and 6. 7 minus 3, 4, 6 minus 6, 0, 6 minus 3, 3, minus 2, 4, 6 minus 5, 1, 6 minus 0. So 0, 1, 4, 3, 0, 4. And base 7. This is your 7's complement of this number, right? And you need to write this number like 0, 1, 4, 3, 0, 4. That's it in your text box. Okay. Any doubt in this? No? Okay. Now the next one is the decimal number is given like this: 7 into 256 raised to 12 plus 2 into 256 raised to 5 plus 1. This decimal number is given. You need to represent, or what you need to do, you need to find out how many ones are there. How many ones are there if this number is represented in binary. So generally what we'll do, 256 raised to 12, right? We'll solve this and we'll find out the decimal number and then we'll convert into binary. But you not to do that thing, right? Let me give one reference. Suppose your number is octal, and that is 3, 4 base 8. This is your octal number. Now this octal number, if I need to represent in decimal, or I need to convert into decimal, how I can convert into decimal? I will write like this: 3 into 8 raised to 1 plus 4 into 8 raised to 0, right? I will write like this. Then this is 3 into 4, that is 24, plus 4 into 1, that is 28. This is the decimal number, right? Base 10. This is also a decimal number, right? What is this? This is just a simplification of this number, base 10. So what is given you? You have given the decimal number in such format, right? So this indicate positions, right? Because this is a position in octal. The same way is a position. Now you know how you can easily convert this octal number into binary. How you will convert? As this is the octal number, you need to represent each digit in 3 bits in binary. So 4 I can write like this 1 0 0. 3 means 0 1 1, right? Because octal 8 2 raised to 3, 3 bits are required. So 3 bits, 3 bits. Now this thing, this, it is a 7 into 256 raised to 12 plus 2 into 256 raised to 5 plus 1 into 256 raised to 0. I can write like this. So what this indicates, in base 256 system, in base 256 system, at position 0, 5 and 12, at position 0, 5 and 12, you have something. Okay. Now, means you have your number at that position. Remaining is 0. At 0, you have some value or digit. At 5, you have some value or digit. At 12, you have some value or digit. Now, this is 256. So, if I need to write, then it will go long 7 at 12th position, then all 0 at 5th position, 2, all 0 means 4 to 1, and then last is 0 is 256. Now if I convert this into binary, this is 256, so 2 raised to 8 bits. So what we have done in octal, take each digit and represent in 3 bits. So same way we'll do it. Take sorry, this is 1, this is 1 at 0th position, right? Take each digit and represent in 8 bits, represent in 8 bits, right? So this is 1, right? So 8 bits means all 7 0 and last is 1. Then here at position 1 2 3 4 we have 0, so they will be all 0, 8 bits are 0, right? This 2, right? 2 means 1 0, and rest 7 6 bits will be 0, 7 1 1 1, then remaining 4 remaining 5 will be 0. So this will be contribute in your number of ones. So how many ones are there? 3 4 and so 5 ones are there. This concept will be used to answer this question. Okay, any doubt in this? Any doubt in this? Okay, so that's why when I was teaching, am emphasizing on such concepts, right? You need to understand such concepts. Okay, now next, which case will generate the overflow while performing addition and subtraction of sign number? So I think this is the straightforward answer. So if you are doing subtraction, then when can there be overflow for sign number? If two signs are different. And in addition, if two signs are same, then there will be overflow. Okay, so this is a straightforward question. Okay, then next is, how many addition operations are required in both multiplication algorithm if your multiplier is minus 20, right? Multiplier is given, yes, multiplier is given, that is minus 20, right? Okay, now in both algorithm, if it is 1 1, right, we are checking q0 and q minus 1, q minus 1 and q0, you can say. If this is 1 1 or 0 0, there will be no operation, right? Only shift operation. But if it is a 1 0, means qn minus 1 is 0 and qn is 1, or 0 1, then there will be some operation. In this case, what is the operation? In this case, ze- means subtraction. Subtraction, right? AC minus BR. Here it's a addition operation or 0 1. Okay. Now your multiplier is minus 20. So first you need to represent minus 20 into 2's complement form. What is the 2's complement form of minus 20? The shortcut method is minus 32 plus 12. So plus 12. This is not in 2 raised to form. So 12 is 8 plus 4. Right? Minus 32 plus 8 plus 4. So minus 32, 16, 8, 4, 2 and 1. Or what you can do, just represent plus 32, represent plus 32 and take 2's complement of it. તો પણ તમને આ જ વસ્તુ મળશે, right? So here I am directly writing it. Okay, and remember this thing, that concept you need to understand, and this shortcut method also you need to remember, right? This will help you. This is minus 32. So first, this indicates negative number, right? And we have a negative number. Now 1 0 1 1 0 0. Okay, so it will start from here and one by one it will move, right? Because at a time we are taking one bit while we are performing booth multiplication algorithm, right? So first case, the qn minus 1, that will initialize with 0, and this is your last bit. 0, no operation, then 0 0, no operation, 0 1, 0 1. All right, so 0 1 means, okay, sorry, 1 0. This is qn minus 1 and this is qn. 1 0 means subtraction, right? So only subtraction. Then 1 1, 1 1 means shift, then 1 0, then 1 0 means, okay, 0 1. You need to, this is my qn minus 1, this is q. Okay, this is last bit in your multiplier. They are both use karo છો, right? And this is the extra bit that we are taking, જે હમણાં currently multiply થતું હશે એ. So 1 0, this is 0 1 means addition. Then next is 1 0, also subtraction. So 2 subtraction and 1 addition in this case. For rest of the things, it will be just a shift operation. There will be no such operation. After this operation, there will be shift operation, right? But in this case, 1 1 and 0 0, there will be no such arithmetic operation, right? Other way you can look into like this: 1 0 1 1 0 0. Make a block of ones, right? The starting of the block, it indicates minus, and the ending plus 1, that indicates plus 1. Starting indicate minus, and there is no ending, open-ended block, right? So no plus sign here. So this way also you can directly interpret that this is minus 1 and this is plus 1 and minus 1. So means 2 subtraction operation and 1 addition. Actually this is called a booth representation, not this one, this one. Okay, minus 1 0, minus 1 plus 1 0, minus 1 0 0. This is booth representation. Okay, so for addition there is 1, for subtraction it's a 2, right? Okay, then the hardware implementation of booth multiplication uses AC register, right? initially that will be all 0. There is a shift operation which performed in AC register as per the algorithm because we shift it. Which kind of shift operation is it? Logical shift or arithmetic shift, right? Right or left shift. So first understand what is arithmetic and logical shift. Suppose your number is like this 101 and you are performing right shift. You are performing right shift. Then 10. This is blank now. This is blank now. Now in this, if you carry this last bit, અહીંયા જે છે એ જ અહીંયા આવે, then this is arithmetic. This is arithmetic. If you just discard this and here every time you put 0, every time you put 0 or 1, irrespective of this bit, then this is logical. This is logical. Okay. In arithmetic shift, you see the latest bits, right? That you will put here. So this is arithmetic. And what we are doing in Booth algorithm, we are shifting like this. So it's a shift right. But which kind of arithmetic? So it's the arithmetic right shift. Okay. Then what is the 2's complement representation of 17? You need to find out 2's complement representation. Representation, right? And I have told so many times that for positive number, the sign magnitude representation, 1's complement representation and 2's complement representation are same. Right? So 17 you will represent like this: 16, 8, 4, 2, 1. This is 17 and 1 bit for sign. This is sign magnitude representation. As this is the positive number, 1's complement representation is this and 2's complement representation is this. All are same. And remember, 2's complement representation is different thing and taking 2's complement. Taking 2's complement. This is 2's complement representation and 2's complement. To take 2's complement of some number, that is a different thing. So plus 17 can be represented like this in 2's complement representation, right? And suppose I want to take 2's complement of this number. I want to take 2's complement of this number. Then first one as it is, rest you need to convert 0 into 1 and 1 into 0. This is I am taking 2's complement of number, and this I am representing number in 2's complement form. Okay. And again remember, for positive number, sign magnitude representation, 1's complement representation and 2's complement representation are same. Okay. And for sign number, if your binary representation starts with 1, it indicates negative number. It indicates negative number. Okay. Okay. Now next is, which is the fastest memory in terms of access time? So cache memory, auxiliary memory, main memory and register. Register is also one kind of memory. You can store bits in your register, right? You are not using that memory, but your CPU is using that. You remember the memory hierarchy, right? At the top we have a register, right? At the peak. So register has a small size, small in size, means in terms of number of bits, but it has a lower access time. Means to get the data from register, it's a faster. So answer is register. The next is how many tag bits are required in direct mapping technique for the given data. Direct mapping, direct mapping technique, and data is given. The main memory has 64 blocks. Capital M is 64 blocks directly given, and cache memory has 4 blocks. See, in cache memory we have 4 blocks. So we need to find out how many tag bits are required. Okay, and it's a direct mapping. As this is a direct mapping, right? Direct mapping, what you need to find out for tag, right? To find out how many tag bits are required, just remember you need to understand that for one cache memory block, how many main memory blocks are in competition. There are 4 cache blocks, right? 4 cache blocks are there. Okay, now these 4 blocks are there, and sorry, I have to clear it. Okay, it's a direct mapping, and main memory blocks are 64 and cache are 4, and you have uh, 4 blocks, right? Now for this block, how many? Because in direct mapping, what you will perform? You will perform modulo 4. For any block number, you will perform modulo 4 operation. Right? And there are 64 blocks, means 0 to 63. 0 to 63, right? So how many blocks are in combination for one block? 0 will give modulo 4, 0, 4 will give 4. So in general, if you divide this 64 by 4, right, that is your, this is 2 raised to 2, this is 2 raised to 6. So 16 blocks are in combination for one cache memory block. For this 16, for this also 16, for this also 16. From this is 64. And what tag bit indicates? It indicates whether the block, particular block that I want out of the 16, that is present in this block or not, right? To address these 16 blocks, how many bits are required? 16, 2 raised to 4. So 4 bits are required. 4 bits are required. Directly, if I need to write, I can directly write like this: log m by n is 2, right? But you should derive this equation. You should understand why this. Okay, so this is the answer for it. 4 tag bits are required. Next is to locate particular word in the block is called, what is block? Block is a combination of word, right? This is a block, and suppose mm, there are 4 words in this, right? So once you locate the block, locate the word. What we use? We use word offset. Require word offset, right? So the correct answer is word offset. Catch offset is to find out which catch block. Tag offset is to find out which catch block. Byte offset If it is a byte addressable memory, then to find out which byte, we require byte offset, tag offset. There is no such thing, tag offset. Now next, you have below RAM and ROM configuration. So RAM and ROM configuration you have. So RAM is 128 address, and from each address you can access 16 bits. And for ROM, you have 256 address, and from each address you can access 16 bits. Okay. The memory requirement is 512 bytes of RAM. Okay, I require 512 bytes of RAM and 1025 bytes of ROM. This is my requirement. 512 bytes of RAM and 1024 bytes of ROM. Suppose if I use this RAM, how many bytes I will get? This is 2 bytes, right? 2 bytes. This is 2 bytes and this is 128. So 128 multiplied by 2, that is 256 byte. So using 1 RAM, I will get 256 byte. So for 512 bytes, 2 RAM. Same way, using this ROM, how many bytes you will get? This is 2 bytes. 256 multiplied by 2, that is 512 byte. This is 512 bytes. And we have 1024 byte requirement. If we divide, you require 2 ROM, right? Any doubt in this? Any doubt in this? Hello. Okay. Now other way to think is like this. In your PPT, it is written like this: 128 cross 16. And this is 512. So 512 cross 8, right? So 512 cross 8 bits. This is my requirement. But using one address, I can access 16 bits, right? 2 byte I can access. 2 byte I can access, right? So I need to divide like this: 256 multiplied by 16, right? I need to represent my requirement like this: 256 multiplied by 16. Then I can write like this: 128 multiplied by 16. This is your data bus. This is your data bus. Okay. Uh, there is lagging in my system as well. Hmm. 16, right? So in your data bus, you can pass 16 bits. Okay. And there are such 256 location. So if you want this requirement, then now just divide it. The answer is 2. This way also you can understand. This way also you can understand this thing. Right? Same concept for Rome. Same concept for Rome. Okay. Now next. Okay. So two-way set associative. two-way set associative. Memory mapping 16 main memory blocks. Main memory blocks are 16 and cache memory blocks n is 4. If I want to put block 5 of main memory, block 5 of main memory into cache, then which set it will go and what will be the value of tag. Okay, so if you understand this, mm, one main memory 16 and cache 4. Okay, so one block, second block, third block, and fourth block, right? So I am representing in this oval instead of that box, right? So there are 4 blocks. Now it's a set associative. What set associative indicates? It's a two-way set associative. Means in one set there are 2 blocks. In one set there are 2 blocks. So first we need to find out how many sets. So to find out there, divide total number of cache memory with the two-way. So it's a two-way. So 2. So it's a k-way set associative. You need to divide with k. Here k is 2. So if you divide it, n is 4 and this is 2. 2 means there are 2 set number 0 and set number 1. So this is set number 0 and this is set number 2. Yes, 0 and 1. 0 and 1. Now you need to find out block 5 of main memory. Block 5 of main memory will go in which set. So what you need to do, block number modulo. This is set way associative. So modulo s. So s is 2. 5 modulo 2 answer is 1. So it will be in set 1. It will be in set 1. In set 1, out of these 2 blocks, it can be placed anywhere. Whichever block is empty. What will be the tag value of it? What will be the tag value of it? Right? So to find out the tag value, you can find out how many blocks are competition for this, right? And you will get total 16 blocks are there and we need to bifurcate it in 2 sections. So 8 blocks are in competition for set 1, 8 are in set 0. So 3 bits are required. But how to find out the 3 bits? Right? You need to write a whole sequence, right? Which will go for 1. So 1, 3, 5, then 7, 9, 11, then 13 and 15, and then start with first 1000, then 001 likewise. Instead of that, what you can do, total blocks in your main memory are 16. To represent that how many bits are required, you require 4 bits. So represent your blocks in 4 bits. 5 is 101 and I need to represent in 4 bits. 4, yes. Okay, so now if I write like this, starting from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, we have block number 4, right? So 0 modulo 2, this is not in our interest, this is not in our interest. No, no, no. likewise. Okay, these are in our interest 1, 3, 5, 7, like this. So 1, so for 1 it is 0, 0, 0. For 3 it is 0, 0, 1. For 5, 0, 1, 0. For 7, 0, 1, 1. I am not representing this number into binary, just I am representing their position, or not a position, means we want 1, 3, 5, 7, 9, like this, right? Because those numbers are in combination for block 1. Those numbers are in combination for block 1. Okay, so for block 5 you can see your tag, that is 0, 1, 0. This is your tag for block number 5. Okay, so it is set 1 and your tag is 0, 1, 0, 0, 1, 0. Okay, for 7 you can do the similar kind of thing. For uh, suppose 8, we want to find out for block number 8. Now we can find out, right? So to find out that 8 is, if I can direct 8, 4, then 2, 0, right? This will go in tag and this is your set, right? This is your set. Wait, so this will be 0, this will be 1, this will be 2, this will be 3, and this will be 4, right? So 4, if you represent, then this is 1, 0, 0. See this? Same way, in our case 5, 3 bits. Okay, so this way you can easily find out. In direct mapping we were dividing like this. Tag bit પાછળ હતા અને આગળ જે હતું એ block હતું. Okay, but here it's a reverse thing. Set is at the last bit, because 2 set only 1 bit is required. If this is 4 set, consider 2 bits. Okay, now next, what should be the value of chip select 1 and chip select 2 to enable the RAM chip? This is a direct question. It's a 1 and 0. This you need to give as an input to CS1 and CS2 bar. Then your chip is enabled. Then suppose your main memory access time is 30 nanosecond and cache memory. Okay, your main memory access time is 30 nanosecond and cache memory access time is 10 nanosecond. What should be the heat ratio? Heat ratio to get 20 nanosecond time average memory access time, T average is given, that is 20 nanosecond. Select most appropriate option. Okay, so you need to find out heat ratio. Generally the main memory access time, cache memory access time is given and heat ratio is given, and then you find out the average access time. This is a reverse thing. So what is the equation? T average is equal to number of times hit. In that case you will find out your block in cache plus miss ratio, and in that case again you will go for main memory access time after your cache. Okay, so this thing you need to find out. So this is HPC plus PC plus TM. Then if you do simplification, minus HPC minus HM. This is T average. Simplify this. Simplify this, and then you will get your h approx 0.66. Okay, this is the heat ratio that you will get. Okay, so if you remember this equation, then this will be very easy. And next is, which of the following memory can be accessed by content? That equation, associative memory. Then the instruction which are permanent and no one change during execution as well are stored in Rom, right? Which cannot be altered. Once programmed, then no one can alter. So the program Bootstrap loader, which loads your operating system, that resides in Rom. Next is again interesting. Uh, x 5 6 7 plus 2 y x 5. Find the value of x and y if the following expression is solved, right? And the answer is also given: 7 1 y x, and these are in octal representation, so number will not exceed 7. Okay, maximum number. So for x and y, the value cannot be greater than 8. This is not possible because octal representation is given. Okay, now 7 plus 5. 7 plus 5 is 12. I am doing summation in 7 plus 5, 12. This is decimal value. This is decimal value. You need to convert this decimal value into octal. This decimal value into convert into octal, right? So how you can convert into octal? Just represent it in binary. 8 plus 4, 0, 0. Now take make a group of 3. Make a group of 3. Then this is 4 and this is 1. Okay. So 7 plus 5, that is 12 in decimal, but 14 in octal. So here 4 will be here and 1 will be here. What is x? X is equal to 4. Your x is 4, right? So now we find out this 4. This is 4. Now do it. 6 plus 4, 10 plus 11. It's 11. Represent it. So 11 is 8 plus 3. Octal. 3, 1. 1, 3 base 8. 3 will be here. 1 will be here. Right? So what is y? Y is equal to 3. Y is equal to 3. We'll do it. Right? We'll check correct or not. So now y is 3. 5 plus 3, 8 plus 9. 9. 8, 4, 2, 1. 1. This is also 1. 1, 1 base 8. 1 will be here and carry will be 1. Now x is 4. 4 plus 2, 6 plus 1, 7. 7. This is a decimal, and if you convert into octal, then it will be also 7. So now x is 4 and y is 3. Any doubt in this? Any doubt in this? No? Okay. Then the last one is x3 base is y is equal to 4 2 base 9. This is given, and what you need to find out, which is the possible value of if the following expression is solved for given 2-digit number. So you need to find out the possible value of x, right? Okay, let's do it. So these number are equal. This number is in base 9 and this number is in base y system, right? So how we can do it? So the common platform is decimal representation. Convert this into decimal and this into decimal, so you can easily compare, right? So how we can write, or how we can convert this number into decimal? X into y raised to 1 plus 3 into y raised to 0. This is base y. Any base system, if you need to convert into decimal, this step you need to follow. Equal to 4 into 9 raised to 1 plus 2 into 9 raised to 0. Now this is xy plus y raised to 0 is 1 plus 3. This is 36 plus 2. Xy is 38 minus 3, 35. This is 35. So now x into y is 35. So now take a factor of 35. So 1 into 35, then 5 into 7, then 7 into 5, and 35 into 1. These are the factors of this 35, right? And if I consider this, first is x and second is y. Now again, another thing you need to consider, your y is base and x is digit in that base. So x must be less than y. X must be less than y. So out of this four, right, which are the factors which follow this condition, x less than y? So x and y, 1 less than 35, yes. 5 less than 7, this is also yes. 7 less than 5, no. 35 less than 1, no. So these are the possible values. So x can be 1 and at that time y will be 35. X can be 5 and at that time y is 7. So in this case, value of x can be 1 or 5. And for y, when it is 1x, the y is 35. When x is 5, the y is 7. In MCQ, right, the choice for x, that is given 35, 1, 6 and 7. 35, 1, 6 and 7. So for x, which is possible 1 or 5. So 5 is not given. So correct answer is 1. Okay. If it is asked how many values of x are possible, how many values of x are possible, then the answer is 2 values of x are possible, or x and y, right? Here it is asked the value of x, and in choice 5 is not given. So this is the correct answer. Okay. Then to solve the following subtraction operation, what will be the result in octal representation? I think that is very simple. One is given in base 16 and another is given in base 2. So whatever is easy for you, you can do it. So either you can convert your base 16 into binary. So now you have two binary number, subtract it, and then take a octal of it. convert into octal representation. Or if you are directly comfortable with octal number, you can convert both the representation into octal, and the result will be your octal number. Or you can comfortable with your base 16 system, then convert your binary into base 16. Now your two numbers are in base 16, subtract it, and then your result is in which form? Base 16. You need to convert into octal. Remember that the result that is asked is in base 8 form. Okay, so this thing you can easily do it.